Hi guys, welcome to application Beautify.ai, and I'm Jude Sajid. I'm going to walk you through the demo. So currently we are in the above page, and from the sidebar menu you have to click on the application, and that would prompt you to a screen where it's gonna prompt your web camera. If you're using a mobile phone, it's gonna get your mobile phone's front camera, and this page is mobile responsive as well. So all the user, what you have to do is just click on this photo, take photo options, which is basically taking a selfie, and voila, the magic is gonna happen. So as you can see, due to lack of sleep, my face is the deformality of my face is mostly puffy eyes and less data on dark spots and wrinkles, and this would change from person to person. And what is actually happening is when I'm processing the image, I'm not processing the entire image with the background. I'm using an OpenCV's face detection model to only just crop my face out of it and do the predictions, and I would show you the code, although it's not shown on the front end. So what's a big deal? So analyzing the skin and identifying deformalities is not a big deal, but how this is gonna help in terms of accessibility in beauty is people with ADHD, OCD, and PTSD, post-traumatic stress disorder. Uh, these specific group of people who are considered neurogenerative find it really difficult to make decisions. So when it comes to a decision making process, it's going to be an intensive and an energy consuming process for them, and they find it really difficult. And me as an ADHD patient, I just could keep talking about it. And so what our application does is it bridges that particular gap. So let's say you want to uh, all you have to do is just take a photo and click on this product links and names. And when you click on show links, what's going to happen is it is going to fetch all the product from the scraped and the preprocessed dataset which we have, that would actually cure or kind of neutralize this skin deformality. So hence it's puffy eyes. I'm guessing most of the products are going to be eye related, and my guess is correct. So we are getting eyeshadows, eyeliners, eyebrows, eye primers and base, blah blah blah. And not just the products, but it would also, we have scraped the data from the internet where it would show the product link to navigate to the actual product where the user could go and buy. And not just showing the product and recommending it to him, this would also generate tips for grooming with the products that has been recommended to the user. For instance, when you click on this generate tips button, what's gonna happen is this is gonna generate at least, let's say, one, two, three, four, five, six, seven, seven different instructions for me for to use all these seven different products. And hence I got puffy eyes. Most of my products are eye related, but you guys could try this app. We are already live at Beautify with AI.streamlit.app, and your results might be different. So here we go. So for the first product, you have to start with a clean base, apply an eye primer on an eye base to keep with the eyeshadow, stay in place for longer, blah blah blah, and then mascara, and then eyeliner, eyebrows, eye primer and base, eyelashes. All right, all eight. So this is what basically the application does, and this is how we are actually bridging the gap in terms of accessibility, especially for people with neurogenerative disorders. So all right, let's go and talk into a little bit of the technical aspect of our product. I just have to mention the product is mobile responsive as well. uh, you could go to the application, and you're gonna get the same input screen. You could take the photo, and It's gonna process, the graphs are gonna come, and you're gonna get your product links, and you're gonna get your detected face, and you guys already know what's gonna happen. So let me go back to the architecture. So what is actually happening is when the image is detected, processed through the web camera or the mobile camera input, we are splitting it into three channels of red, green, and blue. And from those channels, we are generating an image embedding, which is basically a NumPy array. And this array will be the input predictor, the input value for the convolutional neural network model, which is the image processing model that would give us predictions about our skin's deformalities. So as you can see, the convolutional neural network gives three outputs, which is wrinkles, puffy eyes, and dark spots, and not just the classes, but it would also give a probabilistic value which we are using to generate the progress bar. So next, what is going to happen is these outputs are going to be processed into OpenAI's custom fine-tuned model with text DaVinci base. And not just these outputs, but also we are sending the embedded version of the images as strings, which is in array format. And this language model is going to use both of this data in order to recommend the product links and also generate the grooming tips. So as you can see, whatever output I got from, so my example, I got puffy eyes, and most of my products was eye related, and that was pretty obvious, right? uh, but it's not done achieved in a very simple if else condition. um, because for when it comes for different varying cases, this nested logic is not going to help. So you could try the application for yourself, and based on your inputs, what is going to happen is, let's say if you have more wrinkles and less puffy eyes and dark spots, uh, the product recommendations that you're going to get is so far different from what I'm going to get. And what is happening right now here is this cyclic process of generating and predicting between an image processing model and a language model. So this is how the system architecture would work basically. So let me move into the code. This is the app.py file where let me show you the Har cascade. So this is the part where we use OpenCV's face detection module in order to separately crop our face from the background images, which is right here. And we are basically scaling it also. We are cropping it based on the height, width, length, and breadth, and we are just getting the face outside, like extracted from the background images, and all the processing, the deep learning prediction, everything is done only to that face image, which is this. And this is what sets the predictions, and this is what sets the progress bars, which is cool. And these are our this is the OpenAI prompts that we are actually giving in order to generate the text descriptions. And this will be Keras neural network, labeling files, and yes, pretty much that is pretty much it right now. And here we have a about page with just basic text information, and that is it, guys.